Hi, today we're going to learn a bit more about factoring. So right here we have x to the 6th power minus y to the 6th power. And so we're going to have to think about how we want to factor this. So first we notice that x to the 6th power and y to the 6th power are both perfect squares. See, if you write x to the 3rd power squared, that's x to the 6th power. So perfect squares. So now we can use our difference of perfect squares form and write x to the 3rd power minus y to the 3rd power times the quantity x to the 3rd power plus y to the 3rd power. Like that. And so now we can factor this even more because this is the difference of perfect cubes and this is the sum of perfect cubes. So this expression can become x minus y times the quantity x squared plus yx, and it's a plus because this is a minus, plus y squared, and this term can become x plus y times the quantity x squared minus yx, since this is a positive, this is a negative, plus y. And so this is the gigantic factorization for x to the 6th power minus y to the 6th power. Here's another problem. So if we have this intimidating expression here, how are we going to factor this? Well, if we start off by looking at the x squareds and the y squareds, we see that we can classify each of these terms into an x squared term or a y squared term. So if we group these upon the x squareds and y squareds, we get 12a minus 18b plus 24c, and that's all times x squared, plus negative 20c, or minus 10a plus 15b, and that's all times y squared. So we have this. And in this expression, we can factor out a 6. So 2a minus 3b plus 4c, all times the quantity 6x squared, plus, well, in this term, we can factor out a 5, so negative 4c minus 2a plus 3b, all times 5y squared. Well, if we look at these two terms, 2a minus 3b plus 4c, and negative 2a plus 3b minus 4c, we see that if we factor out a negative out of this term, so if we do that, we make this one positive, that one positive, and this one negative, and then this one negative, we see that we have the same term right here. So we can factor this out. So we have 2a minus 3b plus 4c, all times the quantity 6x squared minus 5y squared. And so here is what we get. And if we wanted to, we could force a difference of perfect squares here by doing x squared root of 6 minus y squared of 5 times x squared root of 6 plus y squared root of 5, but we don't have to do that. We can just leave it in integer coefficients, so here's our answer.